Hello everybody, I'm happy that you're here. We will talk today about relational databases. So people talk about modern database concepts, NoSQL databases, streaming platforms, data processing platforms. But the fact is the most prominent databases are still relational databases. Yeah. Who is there? I see how many people are there, but 37. Say hello in the chat so that I know that you can hear me and that everything is fine. So, semi-structured data means data which does not have a clear structure. It is a bit arbitrary. The structure is part of the data itself. So, formats like JSON, XML for semi-structured data. And this week we will talk about XML within a column of a relational table. And next week we will talk about JSON within a column of a relational table. So, by bringing together these two concepts, relational databases with their fixed structure, you have to define the columns with a create table command, and the metadata is fixed and separated from the data. This is brought together with the concept of semi-structured data. So, when people say the advantage of MongoDB is that you can have arbitrary structured documents within a collection, basically this structure is now also there. This feature is now also there in relational database systems, because in Oracle, in PostgreSQL and so on, there is a JSON data type. We'll talk about that next week. And you can store JSON data within a table. Okay, but we will begin with a little history of SQL. The SQL that we use today and that we learn in database lectures at the university and everywhere is most of all SQL 92. So these dots here in this picture are the versions of the SQL standard. So the SQL standard is a document multiple hundreds of pages long that describes the language SQL with all its features and syntax and grammar and how it should be implemented. Whether the vendors like PostgreSQL, Oracle implement it exactly as the standard says is a different topic. So you all know there are different dialects in the end. In PostgreSQL, you say limit 5 to get the first 5 results of a select query. In DB2, you say fetch first 5 rows only to make such a limitation. In Microsoft SQL Server, you say select top 5 from blah, blah, blah. So there are things which are not part of the SQL standard. For example, everything about indexes and performance. That's something the vendors can do as they want. But many things are standardized, and then the vendors of database management systems can say, I agree to the standard, I implement the feature similar to as it is described in the standard, or I modify it a bit. So the first databases were not relational databases. The first model was a network model. So basically like objects in a programming language. You have an object with member variables. Let's say a person object has a member variable name, this is a string, and a city where the person lives, or let's say not city, address. And this address is not a string or something, but of type address. So basically your data forms a graph. Yeah, and the problem there is how to query that data. Give me all people that live in Berlin. There is no query language or something. So the relational model was introduced in about 1970, and there they say, put everything into tables. Create a table. A table has columns, a table has rows. Within the columns, you define attributes, you define the structure of the data, and then you store the data that fits in the columns. And there was one important rule which is called atomicity. Not acid transactions, atomicity, but atomic data types. So atomic means something is not atomic, is not divisible. So you cannot split a data into multiple entries or items. So it is not allowed to say a person has multiple hobbies and then here comma separated list. Oh, Peter has the hobby yoga and piano playing and tennis playing and so on. You have to bring this table in the first normal form and later in the third normal form to have a good table that you can query easily, and it is redundancy-free stored. Redundancy leaves free of redundancy stored in the database. Yeah, I will join the other chat, so when questions will arrive in the other chat. When I read the word join, I thought I should join two chats. So a temporal join on the timestamp when a query comes in the chat, but I know what you mean now. I join the chat by joining it. So now I'm in the other chat. Thank you. So if there are questions, write them in the YouTube chat or write them in the CRIPS system chat in the e-learning system. Thank you for reminding. Okay, so atomic values, and this is something you all know. You know the rules how to make tables like this. And today we will talk about completely different things. We will talk about array types. So there is the possibility to write an array of hobbies here. This was introduced in the SQL standard. And now you ask, why don't I know this? I need this feature. No, you don't. There are better possibilities to do that. For example, like you learned it. We will look at this in a few minutes. But let's continue in this history here. The first implementation of the relational model and of the language SQL was IBM System R. This was a kind of prototype, so it was not a productive system. DB2 is now the database management system by IBM. The prototype for the first relational database system was System R by IBM. It was a research prototype. And you see here's no dot yet, so the language SQL was basically there already. They called it SQL in the very beginning. Structured English Query Language. SQL, Structured English Query Language. But there was another product or another language, I don't know. There was something called SQL already, so there were legal problems with that name. So the easiest solution was calling the language SQL. Some people say it stands for Structured Query Language, so a query language for querying structured data, but the SQL standard itself doesn't say something about an abbreviation. It says SQL is the name of the language, period. That's the name everybody knows. Okay. In the mid of the 1970s, SQL was introduced, and many people still say SQL. So I often mix it and I say sometimes SQL, I say MySQL, sometimes I say MySQL, PostgreSQL. No, not PostgreSQL, this sounds weird, but SQLite instead of SQLite, or Bill Gates, from Microsoft, when he talks about Microsoft SQL Server, he calls it always Microsoft SQL Server, and everybody says SQL Server. So only people who don't know how to pronounce it say Microsoft SQL Server. Yeah, it is mixed somehow. The SQL standard itself gives some hints that SQL is pronounced SQL. And one of this hint is the English language. You say an SQL statement. So they write it an SQL statement or an SQL query. If they would say it is pronounced SQL, then it would be a SQL query, a SQL statement. So the SQL standard says it is called SQL, but people mix it and sometimes say SQL or pronounce it SQL. The first standard of the language SQL was in 1986, the SQL 86 standard. I don't know much about this standard because this is seen as the first standard and then it is updated and updated again. The most important one is the SQL 92 standard. So what you learn in database lectures and books about relational databases and SQL is most of all SQL 92. And in SQL 92, atomic values was the concept of values within tables. So you have data types like varchar for strings with a variable length, integer, decimal, timestamp, date. This is all an atomic, a scalar value. And the first update, which drops this limitation of scalar atomic values, was in the next version of the standard, 1999. SQL 1999 introduced user-defined data types. So you can say, well, a person has an address, and this address is not of the type varchar, because when you write Highway 5, 12345 Berlin here as an address, as a varchar, it is hard or impossible to find all people that live in Berlin. You have to use a like predicate and what's when Berlin is part of the street and not the city. This is not nice. So the best idea would be splitting an address into multiple columns, yes, to support these elegant forms of search. But you can also use a user-defined data type now. You can say create type address type, and now my address column is not of type varchar. The address type is of the address column is of the type my own user-defined address type. And yeah, how you can define this type by like you define a struct or a class in a programming language. It has fields, street, number, zip code, city name, country name, whatever. And then you can store objects of address classes or instances of your user-defined types in this column. yeah, I don't know if you know that. I'm not sure that many people use this feature. You can use this feature. All prominent big relational database management systems support kind of user-defined types, but yeah, in my opinion, it's better to not use them. I will show you later an example. Arrays made it possible to say hobbies is an array of varchars now, not a single varchar where you comma separate the different hobbies or of a person, but you can then say, give me the first, the second, the third hobby, unnest that array, count how many hobbies there are. So each new data type, each new feature that is provided with a new version of SQL doesn't only need a new type definition. There are arrays, but also functions are necessary to work with these types. Count how many elements there are in this array, make a duplicate elimination, and so on. Okay, we will talk about these so-called compound types. Arrays are only one compound type. There's also set, multiset, list, row, union, and so on. We will talk about them in a minute. 2003, it was possible to store XML data within an SQL database. So the XML standard was introduced around 2000 or some years earlier, and yeah, XML and SQL was married 2003, so it was possible to store XML data within a relational table. So instead of saying hobbies is a varchar or hobbies is an array of varchars, you can store nested and arbitrary structured elements here. So for example, you can model this array of hobbies by simply putting it in an XML column. And then we have features like write an XPath query to that to find all people that have the hobby playing the piano. We have functions like counting how many elements there are and so on. So this now is an alternative to the user-defined types. So you can make nesting structures here. Let's say an address is an XML document that has a zip code, street, city, and so on. And you can have semi-structured data there, so arbitrary structured. We have a product table in a web shop. Each product has a price, a description, and so on, some attributes, and an additional XML attribute for everything else. Oh, this chocolate bar has so many calories, and this lemonade has 500 milliliters of content, and this hard disk has 5 terabyte of capacity. So each product has different properties, and you store these arbitrary properties in an XML or JSON format. That is one use case for storing arbitrary additional details. There's a question in the chat. Let me copy it. Let me copy it one moment. I copy it here. And then I click here. is there a performance difference between a 1 to n mapping using foreign keys and an array column? Yes. So yes or no, it depends on what you want to do. When you just want to store data, storing it into an array column is performant, of course. If you want to make analytics, who has in this array column of hobbies the hobby piano playing, then such an array column cannot make use of an index. If the database system supports some index structures on array columns, but I don't know any, if this would be the case, then it would be more performant. But relational database management systems are optimized for atomic data. So the more special cases you introduce, like array, the less they are optimized for these special concepts. So I would still use 1 to n mappings, but we will see next week that when you use SQL JSON, you have the possibility to create indexes on the fields within a JSON document in such a table. Then again, you can increase the performance. But the recommendation is, if you want to have arbitrary structured data, use XML, use JSON. But for the data that you frequently query, extract it and store it otherwise. Store it in a different way. Store it in a traditional way. So it gives you a lot of features, but performance is not the feature there. Then another question here in the chat. So what would be the use case where an array column should be used over foreign keys? No use case. So nobody uses this. This is possible, but I only explain this to you because of historical reasons. So it was introduced, but why should you use it? There are other use cases, other implementations that are much better. So yeah, if there would be a big benefit, then the people and the companies would use that, but maybe in some special cases that I don't know, but yeah, I only introduce it because of history. And the whole talk today is about user-defined types. Nobody uses them. Compound types like arrays. Nobody uses them. XML is dead. So people say, Johannes, you're giving a lecture about modern database concept and you talk about so many things that are dead. Yes? In other universities, they talk multiple weeks about XML. And I don't want to, I only want to give the key concepts from the past to you to understand the presence better. And when you want to become an expert in self-driving cars, you have to know how a driving car works. So we have to look at the history to understand the concepts from today much better. So that's my opinion. That's why I give you an introduction of how the ideas were some decades ago. And this does not mean, oh, we learned in the lecture how to make a user-defined data type. Now we have to change our code from all our projects and use user-defined data types and type tables and structure types and not use the traditional data modeling approaches anymore. No, that's not the case. You should not use what you learn here. Some things, yes, but the most of the concepts is just for understanding the concepts better and be a better database designer and then becoming a database expert. In the next version of the standard, the XML data type can now be queried using XQuery. So when you have this XML data within this hobbies column here in 2006, it was then possible to say XML query hobbies and then for, let, order by, and so on. So you can then use XML query within a SQL function to filter or find something or match expression on this data here. Before that, it was possible with only with simple access methods, accessing via XPath expressions, but here more complex queries were possible within the SQL query by using XQuery, the powerful XML language. Yeah, then 10 years later, it was realized, actually, in the times of the web, when people write APIs, REST APIs, when people use MongoDB for storing semi-structured data, and everywhere else, JSON was more prominent than XML. So the SQL JSON standard was a logical consequence that when we introduced something for storing and accessing XML data, this is now absolutely necessary to invent the same for JSON data. And we will talk about this SQL XML standard today, and you will see next week that there are multiple similarities. We have an XML data type here, we have a JSON data type here, we have a function XML query exists or something, and a JSON exists or something, to simply check whether a JSON path or XPath expression matches to an element or it doesn't match or something. Yeah, and 2 years ago, the most current SQL standard 2019, you see the compound data types, which were introduced here, arrays, they are not dead. So they are still evolving. So they now say a column can not only be an array, but now a multidimensional array, an array of arrays. There are still various use cases for XML. One example being SAP's framework OpenUI 5, where the views are still defined. Views are very often defined in XML. That's true. So even when you develop Android apps, you define the view. So the layout of the app, where should be the button, where should be a text field. You define that in many cases with XML. But XML is well suited for that. So it makes sense to do that. And then you can think, maybe I want to store a layout within a relational table. So let's say you have a web application where users can model their own view of their I know a banking platform, but I don't like that. Within the online banking of one of my banks, I can configure which section should be, and so you can say I want at the top my current list of stocks, and then after that a list of open orders or something, and other customers can make a different look. And then you can say, in my customers table, I store the user-defined layout of the banking application in an XML format like this or something. Yeah. It is not dead, definitely. That's not true. XML is not dead. I found a chart of how JSON is getting more prominent than XML, but XML is still important. Okay, take a look at this ER diagram. This is an entity relationship diagram. In this case here, no relationship, just an entity type. This entity type describes a person. It has a person number, which is the primary key. It has a name. And now it has an address, which has sub-attributes, street and city. And when you learn how to transform this entity relationship diagram into a relational table, then you learn that you have to flatten these attributes and so on. And here, this double circle means it is a multi-valued attribute. So a person has one name and one address, but a person has multiple hobbies. So, and again, this is not possible in first normal form of relational tables. So you again have to do something here. Non-first normal form is the normal form that is even not the first one. So NF square, non-first normal form, means we don't have atomic values. So we have a person number, yes, a name, yes, and the address is not atomic. It is divisible. You can divide it into street and city. So we have sub-attributes here. It looks a bit ugly. In Excel you can do this. You can split a column into two columns and so on and make sub-columns. But that's not easily queryable. And you can imagine that it's not easily queryable when you could do this in SQL. And you can do this with SQL. You can say address has the type row, varchar, street and city. And then you can say select star from people where address dot city equals Berlin. So you use a dot syntax for going deeper in the nested structure of sub attributes. It's possible. Our hobbies column, this is a very bad example using commas here, separating multiple hobbies with a comma. So why is this bad? Let's say a hobby has a comma in its name, so you have to escape it somehow. How to count the number of hobbies? Okay, count the number of commas, but not the escaped ones, and then plus one. How many people have the hobby yoga? Okay, you have to use a like predicate or something. It is not nice to query, and optimizing this with indexes, no chance. So this is not nice, storing a multi-valued list like this. So in my database lecture, you learn how to transform this into the first normal form. I don't know if you all learned this in the database fundamentals lecture, but oh, sorry, you did not see it. So I ask you, go to frage.de with double A. When you bring this table in the first normal form, how many tables do you have then? Do you have 1, 2, 3, or 4 tables? Use your mobile phone or browser tab to go to Frage with 2a.de and give me the answer to these questions. You transform this ER diagram with a complex attribute and a multi-valued attribute. How would you end up with how many tables? When 35 people have answered, I show you the solution. So 5 more, please. Go to frage.de and vote how many tables would you have. Basically, in an ER diagram, you have for each entity type a table, for each N-to-M relationship another table. Here we don't have relationships. Okay, now I give you the answer. We have 2 tables here. So this address is no problem, because simply say we have person number, name, and no address column at all. Simply say we have a street and a city column. This does not change a lot. But for the hobbies, we have to split this. So our result looks like this: person number, name, and then I give it the prefix address underscore street and address underscore city. It's not necessary to do so, but then we know, okay, these 2 columns belong together. They build the compound address value, and maybe you have more attributes, born in or something, and then you have a date, a birth date, and born in a city, and then you again have city. Then it's better to distinguish, this is the city where the person lives, and this is born city, the city where the person is born. So yeah, when I transform something from sub-attributes into a relational schema, you simply flatten the structure. So like this, as if street and city would be first class citizens, first class attributes of person, but give it a prefix so that you see that it belongs together. And the second table now forms this multi-valued attributes here. So it models the multi-valued attributes as a separate table. We have the primary key from the person, so a person number, and an hobby. So both together is the compound primary key, so that one person can have many hobbies, and one and the same hobby can be used for multiple people, of course. So Peter has 2 hobbies, piano and yoga, and we split it into this table into 2 rows. So when we would now join this table with that table using the person number, we have 2 rows which tell us Peter lives in Berlin and plays piano. Peter lives in Berlin and has the other hobby, yoga. And then you can use SQL for asking how many people have the hobby yoga, how many people in Berlin do have the hobby piano, and so on. This is very nice. Okay, in 1992 I told you, oh sorry, there's a question in the chat. First normal form demands unique values per cell. No, not unique values per cell. Unique would be no duplicate. atomic, you mean. Wouldn't we need to have an address table to adhere to that? There could be more than one person at the same address. That's no problem. This is not, this does not have a unique criterion. There's no unique constraint on the column here. So first normal form just means atomic values. Values of one scalar data type. No structs, no arrays. That's first normal form. It's no problem that people have the same address. People can have the same name, people can have same hobbies, and people can have the same address. That's no problem. User-defined data types, UDT. UD is an often used letters in databases. UDF, user-defined function. There are built-in functions like lowercase, uppercase, length of a string, convert a date into a string, parse a string into a timestamp, and so on. Built-in functions. And there are user-defined functions, which you can create and use if and while and return and so on to develop your own functions. There are built-in data types like int and decimal and so on. And there are user-defined data types. And where can you use built-in data types? For column types, I can say I create a type address as it is a structured type. So my own type has a structure. It is a complex type that defines an address that consists of a street and a city. So this is actually called structure type. There's another user-defined type alternative, which is called distinct type. It's just renaming another type. So you can create a type length as integer. So you simply rename an integer into length in meters or something. The only benefit of this is that you cannot compare a length in meter with another distinct type, which is also based on integer, which has a square meter or something, just to make the domains distinct, to make them not comparable from each other. But we don't go into detail with that. Structure types means you define your own user-defined type and giving it a structure like a table. So your type is like a table, but it doesn't have a primary key or something. You can have the properties like check constraints, unique, I don't know, depends on the system. But typically you just say my type is a compound type of, not a compound type. My type is a structure type of these attributes. Yeah, there was exactly this question in the chat. With the type errors. Will there be type errors if one tries to compare int to length? Yeah, exactly. That was the motivation for introducing distinct types, that you avoid that you can compare things that are based on the same type, but they are not the exactly same type. So if you really want to compare int and length, then you have to use castings. Then it's again possible. Isn't person hobby an M-to-M relationship? No, because an end-to-end relationship is a relationship. It models similar things. Oops. You can say a person has hobby, but then a hobby needs a primary key and so on. So in the ER diagram, our model looks like this, and the question is how to transform this into a relational schema. So if here would be a relationship, then yes, then you are right, then you create a table anyway. But this is a bit different. It is a multi-valued attribute. Okay, so here you see one use case of user-defined types. You can use them wherever you also can use built-in types. For example, this column is of type varchar, name is of type varchar, and my column address is of type address. That's possible. You can also define user-defined functions that return an address now. You can define functions that return integer, functions that return Boolean, and now you can return a function, you can write a function that returns address or takes address as an input parameter or something. So you can use your user-defined types wherever you can use built-in types. And here we use it for a column. The SQL standard also introduced type tables, that you say create table people and, or let's call it create table addresses of address. Then this table doesn't have columns. You just say in this table I store address objects. This is supported by DB2. I don't know another database system that supports type tables, but yeah, why should you use them? And here you see some examples how to work with these user-defined tables. There are constructors, like in a programming language. You use new and you say new address. So each user-defined type has a default constructor and it has getters and setters. Here they are called mutators and observers, but basically they are methods to access an attribute. For example, here is basically that is a getter. Address.city gives us Berlin. You use the dot syntax. So this is how the SQL standard says how to use, how to work with user-defined types. And when the vendors started to implement this feature, they said, this is a problem by using this dot because the dot is already used to table name dot column name. How do I know whether this is a table and this is a column, or this is a column and this is a subtype of the column? And then crazy things happened, like DB2 said, okay, you have to write dot dot. Others said, I don't support user-defined types at all. So yeah, this is not often used. In PostgreSQL, you see how they solved it. You have to write it in brackets. This is not possible to do for table names. So you can say people.address and then that.city. Then you have to write people.address in this column. So this was their trick to support now the dot syntax for accessing the attributes, the subfields basically of a user-defined data type. And the rest is quite similar. So you can simply use PostgreSQL, say create type, then you have this type, create table, use this type from now on as a column type. PostgreSQL does not use this new constructor here for instantiating values of user-defined types. Simply a bracket syntax is used, so you write the values for all member variables within parentheses. There's a question in the chat about the SQL standard. Does the SQL standard only define features but not the syntax? Or how is it possible that multiple implementations of the same standard use different syntax? The SQL standard defines syntax. Let me open an, one moment. Let me open a SQL Standard document. SQL Standard is not for free, so this here is a draft. It is publicly available, SQL 92. And there you see that each feature is somehow documented. Null predicate. Let's go to the null predicate. 8.6, and it says row value constructor is null. So the SQL standard defines the language. And it also defines some rules. So if all the values in R are the null value, R is null is true, otherwise it's false or something. So it describes the syntax and also rules. For example, between predicate. So you write a column is between a value and another value, and it describes how this should be evaluated. So to avoid that each and every database system implements it in a different way. So it describes both the syntax and the semantic. In the moment I write a dot when accessing a table, I know if it must be a new type. Where am I wrong? Let me open database to show you the problem in this dot syntax. I use the dbeaver as a database client. Let's clean it. So create table A. It has a column A. And let's create type A type, which again has a column A. Okay, I create a type A type, so like I created a type address that consists of a street and a city, and now my table A has an attribute A of A type. Okay, A.A from A. Yeah, is this now the table A and the column in the table, or is this the column and then the subfield in that column? So do you see the problem now? That's why DB2 implemented it like this. They say when you mean a sub-column of a column, you have to write dot dot. The SQL standard says this, but so here for, let me insert something, insert into A, values 5. Column A is of type A types, but there's an integer. Let me look in the slides. I use brackets and do I need a second attribute? No, here. B also, I use a char1. Drop type A type. So I cannot drop it because there's a table that uses this type. So I drop table A, then I drop the type. Now I create the type, then I create the table and I insert something. And now it works. Okay. I don't know the syntax how to create a value of a type that has only one field. And now this, oh, nice, nicely displayed here. My dbeaver client actually shows it with subcolumns here. This is the column A. It has the subcolumns A and B. So A.A stands for from the table A, give me the column A. And when I want the field A from the column A, I have to write it like this. The thing was that people cannot distinguish between table name or type. Yeah. Only if I alias the table A. If I'm not aliasing, I will specify the columns within the select and then it must be a column. Yeah, you are very flexible in SQL. So you can alias it, you do not need to, and there must be a strict rule. And implementing a parser is really hard, especially when there are special cases like before the dot this can be a table name, it can also be a schema name, and before the dot can be a column name. So this makes it hard for parsers, especially when this is a feature that is introduced after some years, when you have already existing code. PostgreSQL was already there in 1999, and maybe this was the reason, because it was too hard to add this feature, this syntax for being downward compatible and so on. Okay, I will show you how the SQL standard defines things, and then in most cases I use PostgreSQL as an example. Here PostgreSQL says, yeah, don't use here the new and so on, and use this syntax here. Create type also has the feature of subtyping. I think PostgreSQL create type supports also subtypes. Create type and then a comma separated list. And now here. The SQL standard says you write under. Create type German address under address. Under is basically the extents of SQL. But okay, again, PostgreSQL does it a bit different. You define somehow subtypes. So you can implement subtypes of user-defined types. And now I ask you a question. Go to frage.de. What do you think? Values of which data type can you store in the column of type address? So which values can you store in this address column, which has the address data type? Again, when more than 35 people answered, I will show you the solution. In between, there's a question in the chat. If PostgreSQL uses address.street, address in parentheses, it deviates from the standard in this point, assuming it does not also support the address.street syntax. Yeah, exactly. It differs from the standard. I'm not sure what the standard would say about this query here, but the standard would allow this a.a.a. This is not possible in PostgreSQL because in PostgreSQL you need to use the brackets, the parentheses here. And when this table called A would be in the schema A, then it is even more complex. But I think the schema name has to be used here. So this is not a problem at this point when accessing a column. Okay, 5 more answers, please. Which values are you allowed to store in this address column of type address? Address is my user-defined type, and I told you that it is possible to create subtypes. Okay, I give you the solution, address and its subtypes. So you can store subtypes of addresses here. This is similar to a programming language. So when you have, for example, Java, and you have a class address class German address extends address, and then you say address A equals null or something. Then you can say A equals new. This is I created a class with a lowercase character at the beginning. Don't do this at home. Of course, you always write uppercase here, or upper camel case here. So you can store an address object in A, but you can also store of subtypes here. This is called polymorphism. So whenever I expect something of type address, also a subtype is accepted here. In Java, you can say I have an object, and you can store in this object a number or a string or a new address or something. So you can always use a subtype when the type itself is required. And here the same. So when you have an address column, you can store address objects, but also instances of a subtype. And then there are constructs like instance of, so to check whether it is now a German address. There are castings, upcasts and downcast, and so on. Is there a database management system that implements the SQL standards without deviating? No, there isn't. So the most closest one to the SQL standard is DB2. So the thing that I said fetch first 5 rows only. This is in the SQL standard, and DB2 uses this syntax. DB2 is very close to the standard, but of course not without deviating. So every dialect is different from the standard language. Then in 1999, the complex types were introduced, or composite type. Composite, you use multiple things within one type. So now our address is not an own type, but an address is a row that consists of street and city. So basically this is similar to an own type, but when you define a user-defined data types, you define it with a separate statement, create type address, and then you use it in this table, in that table, and so on. Here you define basically the structure that address has the sub-column street and city within the table itself. And here you see that it is similar of creating now a new row. So this is now an address row, and you build that row with a row constructor here. And hobbies is a varchar array of maximum length 3. So you can store up to 3 hobbies here. In our case, we store the 2 hobbies, piano and yoga. You can then use an array like you know it from programming languages. Give me the second hobby. So it gives you yoga. So it starts counting with a 1. And you can access the sub-attributes of an attribute of a row with a dot syntax again. Address.city. This is not PostgreSQL. This is SQL Standard. So PostgreSQL does not support this row here. DB2 does. How is a table written into memory if a column can contain a subtype with additional data? That is not a problem. So when you define such a row here, it can internally reserve 400 bytes for the street and 160 bytes for the city. Let's say each character is 2 bytes plus maybe a length indicator or something. So there's nothing special in that. So so 1, 2, 3, 4, 5, 6 data types were introduced by the SQL standard. No, actually only these 3 green, but there are basically 6 data types which we can think of when we talk about composite types. First of all, we have to say, are there homogeneous elements in our type data? So for example, hobbies, yes, these are only varchars. So the first hobby is a varchar 100, the second hobby is a varchar 100, and so on. So if we don't have homogeneous elements, then we can use this row here. Here's street is a varchar 200, city is a varchar 80, a number can be an integer, the zip code can be a char 5 or something. So this is used for row types, homogeneous, heterogeneous elements in this case. A union type is basically thinkable, but it is not introduced by the SQL standard, which simply means, oh, I have a column in which I can store the union of integer and timestamp and so on. So you can store an integer or a timestamp there. Nobody uses that. When we have homogeneous elements, like here for our hobbies, there's a distinction: is the collection ordered or not? Ordered elements are arrays or lists, And the difference between arrays and lists are arrays have a restricted cardinality. So here in this hobbies array, we say array 3. So we can store up to 3 varchar 100 values. And a list is, has an arbitrary size. It's not restricted. Row, array, and multiset are standardized by the SQL standard. So there are no lists, no union, and no sets. And they simply said when we have an unordered collection, we have a multiset, and there are then functions to check whether a multiset is a set. So it is called isSet. It returns true if there are no duplicates, and it returns false if there are duplicates element within the set. So the SQL standard introduces only multiset. And there's a function which converts a multiset into a set by simply removing the duplicates. Here I show you two things that you can do with arrays. So the first thing I already told you, accessing the second hobby. So in this case, yoga, from people which have in the address the subfield city Berlin. And here, this is now within the from clause. So here we use it in the select or where clause. Here I now use our hobbies column in the from clause to unnest the array. So basically, this looks like what we had here. So as if this would be a table and the hobbies would be a separate table. So like joining these two tables is now possible by unnesting this. So this is like an automatic join here. So we have now every person with its name and maybe other columns if there would be other columns. And then for each hobby, each person appears once. So if Peter has 2 hobbies, then this query returns twice the person Peter. First with the hobby piano, then with the hobby yoga. And with this you can transform something that you have in an array now into a separate table or a view, or you can use this in a common table expression to make a query or something. We will see such unnest queries which you use in the from clause also for XML and for JSON. PostgreSQL does not support multiset and row. So row, multiset, and union were introduced in the SQL Standard 99. PostgreSQL just said array. That's it. So you can say a table has a column of type. This is the base type. So each element in the array is a varchar 100, and then the keyword array. And here you see PostgreSQL does not require a limitation. In the slide before we said array 3, and PostgreSQL said, well, actually this is an array with an arbitrary size, so basically it is a list. They call it array. And then they use a syntax. Yeah, I wanted to say this is close to JSON. No, it isn't. It uses curly brackets and no double quote characters and so on. So you simply use a string with comma separated values within curly brackets to construct something of an array type. So you write a string and PostgreSQL uses a transformation to transform it into the array by splitting this string into commas. And then in the end, you have an array here. So let's copy paste this into dbeaver. Drop table person. There's no table person, okay. People it is called. Drop table people. Then I create a table people. There's a name and hobbies array. Let's look into this table. Okay, name and hobbies, 2 columns, name and hobbies. And then I insert a person with name Peter and hobbies, this array with 2 values. And yeah, it shows me piano and yoga. And when I say hobbies 2, I can access the second array element. Where piano is any of the hobbies. This is something that PostgreSQL introduced. So is in hobbies something that is called piano? Okay, yes, this is the case for the row with Peter. And then this unnesting unnests the array and blows up my result. So Peter appears now as often as he has hobbies. Let's add some more people. So let's add Carla and Anne. Carla has only 1 hobby, tennis. No, also piano, so that we find her with the second command here. And let's Anne has no hobbies at all. So hobbies 2 gives us null for the people that don't have a second hobby. And piano now finds Peter and Carla. And the unnest will hide Anne. So Anne is not found here. Similar to if you join the 2 tables that we saw before, the row with the person Anne does not find a join partner in the hobbies table, so it is not here. If you want to have it here, yeah, you have to do some is empty checks or length checks, I don't know. So she's not here. We have now 3 rows, twice the Peter because Peter has 2 hobbies, and once Carla because she has 1 hobby. Do SQL arrays indices start with 1 instead of 0? Yes. So in my slides I always use make this clear with using something which would not be possible when it would be in the other way around. So I write hobbies 2, then it's clear, okay, it starts with a 1, otherwise there would not be a second hobby. It starts with 1, yes. Then another question in the other chat. Where's the window? How would you insert something like foo, bar? Yeah, there are escape characters. You have to escape your commas and curly brackets when you need them. Look into the documentation how you do that. I think you have to use escape characters or something. I don't know. Yeah, another question for you. Go to frage.de. What do you think does the following column I in the following expression show? So here I introduce hobby and I. Unnest hobbies with ordinality as H, hobby I. So what do we have in I? So I would write it like this. h.I, h.hobby, from people, honest hobbies with ordinality. So what do you think does the I column show? Answer quickly, because we don't have so much time left. 20 seconds left. 10, 9, 8, 3, 2, 1. The element's position. Very good. So it shows Peter 1, piano, Peter 2, yoga, Carla 1, piano. This is possible because arrays have ordered elements. We can say, give me the second hobby and give me for each hobby the position. Ordinality is a word. I didn't find it in my dictionary. So where do you use the word ordinality when not in SQL? Okay, let's come to the XML part and a little teaser for next week, the JSON part. So it makes it possible to say this column is of type integer, this column is of type varchar 100, and this column is of type XML. This is also of type XML. No, this is of course of type JSON. So in this case, we have a JSON array here, and this is of type JSON, and we have a JSON object here. In XML, the standard says that you can say address is of type XML, and you can say address is of type XML that matches the following XSD, so the following schema. So you can say not arbitrary XML documents allowed here. You must have the address root element and there must be a street, so you can have a schema here. This is not possible for JSON, but of course you can use check constraints. You can simply say hobbies JSON and then check JSON exists, blah, 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 blah. So with that you can have arbitrary integrity constraints that the JSON object has to have an attribute job or something. So our example from the beginning, where hobbies was an array or a multi-valued attribute, is now solved by saying hobby is a JSON and address is an XML with the subtypes street and city. Here we also introduced the zip code as an attribute. And I added another field to tell you one use case, or the most important use case for XML and JSON in relational databases, for storing arbitrary stuff. So every person can have different additional properties in the profile attribute. Here we can store the jobs of the people and if they are married or not, or if they are divorced, and all details, what else, which are the favorite books of that person. You can store arbitrary things here. Semi-structured data. The structure is part of the data. There's no column job. It is just here in that JSON element. 2003, there was the XML data type. It is a native data type, so you can simply say, here, my table has hobbies XML. Bam, it is finished. You can now store XML data here. I prepared something, bit.ly/SQL XML with this table name and address. So we store people in our people table. They have a name, varchar200, and an address as an XML. So I use DB2 here because DB2 is the closest to the SQL standard. We can use XML in PostgreSQL, but it differs a bit. So what do we do here? I create the table, address is an XML. I simply write the XML as if it would be a varchar, as if it would be a string here. Address, street, closing the street again, city, blah, blah, blah. And then you can use XPath and XQuery. So the SQL standard says passing address. It passes the XML that it is in the address column, and we can now use XQuery to say, I want the city and then the text. If you would not write city/text, but only city, this is dbfiddle.uk. It executes your commands on a real DB2 database. Okay, it is now displayed the same as before, but actually this is now, it should look like this, but it is displayed like this in the dbfiddle because it simply omits everything that is not a text node. So basically this would be the result of //city, but when I say //city text, I can go //city add zip to go into the attribute of the zip code to get the zip code. Yeah, here it is. Which people live in a city? It is possible to answer these kinds of questions with give me the zip code. So select star from people, where, and then XML query, go into the zip, and then equals 10, 1, 2, 3. This is possible, but very expensive, because this expression here has to be executed for each row, and then the result is checked whether it is 1, 0, 1, 2, 3. It is much cheaper to do the predicate check as close to the data as possible. So we use XPath or XQuery to check, does this person have a city with a zip 0, 1, 2, 3? If yes, then something is found here. And when something is found in an XML exists predicate, then it is evaluated to true, otherwise false. So this is much more performant than that here. XML exists just checks whether this expression finds anything or not. And similar to this unnest for arrays, here's an XML table which has an XPath expression, for example, /address, that was the field with two subfields, street and city. And then you, so this goes into the address, and from that context node you say, okay, I want to go into the city/attribute zip and into city, and I split my XML data into multiple columns. So this brings your structure back to a table structure. So in the end, you need a table structure again. Okay, this is XML in SQL. I want to very quickly show to you, so these were the examples from the dbfiddle. I want to quickly show to you how to use this in PostgreSQL, but this is very close. But PostgreSQL does not support xQuery, only XPath. So first of all, it's very similar. You say address is of type XML and you store the XML document in there. And PostgreSQL uses a function XPath, which has two arguments. First of all, the XPath expression, and then the field of type XML where you want to execute this XPath expression on. So this is basically the same as before. For each person, we go into city/text. So we find for each person the city Berlin here. A last question for you, then we are finished. What's the data type of the XPath query? What do you think is the data type of this expression here? What's the result of XPath? What does this return? XML, XML array, varchar or varchar array? Write your questions now in the chat, then we can quickly discuss your questions in the end of today's lecture. I will show you the solution. I guess that many people answered something with varchar. Yeah, I'm right, because city is a varchar, but XPath does not know what your data looks like. So somebody developed the function XPath, and and this person has to say returns da da da. So it cannot return a varchar today because the city is a varchar, and an array today because we have multiple cities, and tomorrow it returns an integer because we use a different expression that accesses this. No, that's not possible. So XPath always returns XML array. That's the generic thing. XML has a tree structure, but an expression can match multiple times, so the result of an XPath expression is a sequence of nodes. It is a forest, and in PostgreSQL, a forest is an XML array. So when this expression that we use here matches 5 times, because a person has 5 city elements, whatever, then the array has 5 elements, and within each element we have either an element node or a text node or an attribute node, but that's the result of XPath. Okay, and then the same query from before. XPath exist is possible in PostgreSQL. That was here. XML exists. So this what just checks whether an expression finds anything or not. If yes, it returns true. So if there's a person who has in the XML the zip code 10123, then it is found. So that's how to make predicates there. Okay, that was the lecture of today. Do you have any further questions? Next week we'll do the same and more details. This was just historical. You don't use XML and user-defined types and arrays so often in reality, but for using JSON, you will see similarities. We will go into more detail. We will look at unnesting for JSON. We will look at building JSON. We will take a look on index support of databases for JSON data, how different vendors do it differently. That's what we do next week. Okay, I don't see any questions. Then thank you very much for attending today's talk about XML and SQL, compound types and user-defined types. I hope you learned something new, and see you next week. There will be an exercise. Yes, it will be uploaded this evening. So there will be a little exercise about what we did today. See you. Goodbye.